Hi, I'm Paul Beckwith. I'm with the Laboratory for Paleoclimatology at the University of Ottawa. My website is paulbeckwith.net, and please consider supporting my work, which is completely self-funded in the production of these videos, etc. So in this video, I'm talking about the phytoplankton declines in the ocean. So in 2010, this paper and a whole bunch of news articles hit the site. Were out in the media cycle. Phytoplankton population drops 40% since 1950. Since phytoplankton are the foundation of the ocean food web, and they're declining, this is a very, very serious issue. So let's look and see what's happened in the 5.5 years since this paper came out. Is the situation worsening, getting better? What's happening? So this is the original paper in Nature that came out in July of 2010 and triggered all these press releases. So what they measured is, well, phytoplankton account for about half the production of organic matter on Earth. So you can use satellite data to look at concentrations since 1979, and these have suggested that there might be reductions, but the length of this record is not very long. So there's lots of other measurements where people scoop buckets of water out of the ocean and measure the clarity of the water and can get ideas on the number of phytoplankton. And if you put all this data together and divide the ocean into 10 different regions, the conclusion was a decline of 1% of the global phytoplankton per year. So how do they come to that number? They sampled these are samples over time, and in situ samples here. The distribution is here. I won't go into the details, but this is the 10 regions of the ocean, how it's divided up, and this is the rate of chlorophyll change. So this is the decline of phytoplankton. If you're to the left of this line, it's a decline. If you're to the right of this dashed line, it's an increase. Since 1989, then we have the red spots, and since 1950, we have the blue. And if you look at the Arctic, the South Atlantic, the Equatorial Pacific, those are the regions with the greatest loss of phytoplankton. You can get the graphs here. This goes from 1900 to about 2010, and this is the different regions of the ocean. So the Arctic has shown very sharp declines of phytoplankton, similar to the North Atlantic, the Equatorial Atlantic, the South Atlantic. There's declines. It's funny, there was initial rises here, but then there's been very strong declines. So the South Indian Ocean is showing an increase, as is the Southern Ocean, but all of the other regions are showing a decrease. The data is also separated into average seasonal data. So this is over the space of a year. So in the polar regions, for example, the blue line is the northern region, so there's more phytoplankton in the summers and less in the winters, which is expected because of the sea ice cover. And in the southern hemisphere, this is their winter, or this is their summer. It's reversed from here. So, sorry, this is their winter here, and then this is their summer here. So this makes sense, and also in the Pacific regions and near the equator, you get less variation. If you take, so getting back to the conclusion, about 1% decline, it's actually about 0.86% per year decline per year. If you take 0.9914 and take that to the exponents to the power of 60, you get a 40% decline. So add 5 more years to that, take it to the power of 65, and that is closer to 43% or so decline. That's if the decline in the last 5 years is occurring at the global rate, but maybe it's not, and there's reasons for that, and I'll talk about them in a minute. So this just shows some images of the phytoplankton. So there's all these different types, of course, different sizes, different types. Some of it is based on silicon dioxide or glass backbone, like diatoms, and the coccolithopores, the foraminifers, forams for short, are based on a calcium carbonate backbone. Of course, with ocean acidification, those backbones cannot be formed as well, and this will threaten those species of phytoplankton. So there's all these different images of different types of phytoplankton. These are some more images. These are scanning electron microscope images of different types of phytoplankton. So there's a whole proliferation. There's a whole different world of phytoplankton types and things, and their numbers are greatly reduced, as I was saying. So this is, what do phytoplankton need? Phytoplankton, they need sunlight. This PAR is photosynthetically active radiation. So this is the sunlight that is involved in photosynthesis. The UV is harmful. It can harm the phytoplankton directly or create pollutants, which can then reduce the numbers. The pH of the ocean is important. As I mentioned, if the ocean is more acidic, then the phytoplankton numbers are reduced. CO2 is responsible for lowering the pH, making the ocean more acidic, but it's also required by the phytoplankton. Like any plant will require CO2. You also need the nutrients supplied, and the temperature is an important factor, because if the temperature is too hot, then the mixing layer over which the phytoplankton and the nutrients and everything is there to produce the phytoplankton, that mixing layer depth decreases. So the thickness of the layer decreases and there's less phytoplankton produced. As the temperature rises, phytoplankton, like any other plant, there's an optimum temperature for maximum production. And if you exceed, so the yield will increase to a certain temperature and then it will decrease. So if you get more stratification and higher temperature, then you can get a decrease. You also need the nutrients to get up here, so you need the vertical mixing. And the wind affects the wind patterns can cause a disturbance on the surface and bring up nutrients and also affect the mixing layer. So these are all the factors, the components. And if we look in more detail here, this is showing the same thing, the different types of phytoplankton groups. Of course, dissolved organic matter and dissolved inorganic matter can affect things. And also you have particles in the water, and that can reduce the clarity of the water. So the transmission of light decreases through the water, and that can also reduce the phytoplankton levels. But it also can if the water is extremely clear, then you get more UV going through, which can decrease the levels. This is just some things about phytoplankton. Amazing phytoplankton, the most important organism on planet Earth, you could argue. The basis of the entire food chain in the oceans. The same as the oceans, the entire marine ecosystem contains 400 times more energy than any known plant. I guess that's the ensemble of the plankton. Food produces more oxygen than all the forests combined and things like that. So this is just some of the different types. I mentioned diatoms, dinoflagellates, and I can't pronounce this name, green algae, blue-green algae. So there's many different types. And this shows a schematic of, basically we've got the phytoplankton up here, large phytoplankton, the zooplankton come up to feed at night. Then there's the carcasses of the dead phytoplankton sink down, or the zooplankton that eat them and excrete them, that sinks down, and these particles can start being decomposed by bacteria, etc., can sink into the seafloor, and this is a way of storing the carbon. So if we're changing the layers, because we're warming the ocean, we're stratifying it, we're disrupting this whole process. Now this shows where the different sizes of phytoplankton like to hang out. So this is the entire phytoplankton community, and this is the really tiny ones, 0.5 to 2 micron, the distribution, so they're more at the poles. These are the nanophytoplankton, 2 to 20 micron. There's more of them up here. And notice the microphytoplankton, 20 to 200 micron are up here. So if you add all these three, then you get this. But notice that there's a lot of them in the Arctic. And what part of the ocean, what part of the world is changing more than any other part? Well, the Arctic, because of temperature amplification. And this temperature amplification, this is a surface temperature, 2 to 4 degrees warmer in the high Arctic between 2011 and 1960. You can see the distribution of temperature, the zonal mean temperature. If you take a zonal average around the whole Earth and plot it as a function of latitude, you get this type of thing. So the Arctic is warming so much, so most of the stratification is going on in the Arctic, and this is going to reduce the phytoplankton, which will then make the CO2 levels be even higher. So this is a very strong positive feedback. So what's happening more recently since that paper? Well, this paper just came out about a week ago, phytoplankton disappearing from the Indian Ocean. If you'll remember the graph from the previous, from that 2010 paper, it showed that the Indian Ocean was one region where the phytoplankton levels were actually increasing. Well, maybe not so in the last 5 years. This actually shows that in the last 16 years, the phytoplankton in the West Indian Ocean have fell 30% over the last 16 years. So if you want to look at the, this is the paper on the Indian Ocean, the source of that paper. So reduction of 20%, reduction in marine productivity is attributed to the rapid warming of the Indian Ocean. Future climate projections indicate further warming and subsequent reduction in marine productivity. So these are very serious issues, and there's lots of data in this paper. It shows, so this is the Western Indian Ocean, the summer chlorophyll trends, and they're dropping, and this is where the sea surface temperature is rising quickly in those regions. So it's a clear correlation. The warmer water, stratified, less phytoplankton. We know off the Gulf of Maine the water is extremely warm, and this is because the Gulf Stream characteristics are changing because the Arctic's warming so much. Well, look at the phytoplankton in the Gulf of Maine as measured by a ferry that goes every day between Portland and Yarmouth, Nova Scotia, and you can see that the level has dropped from 2001 by about a factor of over four. So this is very, very serious, and the water in the Gulf of Maine is warming almost faster than anywhere else on the planet. There's many, many different stresses to phytoplankton, as I said. The biggest is the lack of nutrients. Ocean acidification is also an issue, and there's other stressors and other issues, and they're covered in great detail in this paper. This is the pH of the ocean. The open ocean was about 8.2 over 35 million years, and since then it's dropped to an average of about 8.1, 8.05, which is a 30 to 40% increase in acidity. Get down to 7.8, 7.9, 7.8, and you have a huge problem with the base of the food chain, the phytoplankton that have the calcium carbonate shells. So what happened in very recent papers, okay? So this paper, Recent Decadal Trends in Global Phytoplankton Composition, came out in October of last year, and it's talking about the declines over the ocean, the percentage decline. So if I go to the chart in this paper, this is the globally, the mixing layer depth has decreased by 1.76 linear difference, so 1.76 meters. The temperature has been rising, so the nutrient levels are lower, and therefore the amount of diatoms are lower. In the North Pacific, we have an enormous drop. North Central Pacific, another drop. I mean, we're getting all these warm blobs in these regions, so the drop is huge. Look at the drop of nutrients, huge percentage drops. Since huge linear difference rather than between 2012 and 1998. Huge numbers. Also, South Indian Ocean here. So all of the data is here. You can stop the video and have a look, or you can just go to the web, go dig up the paper yourself. So this is a diatom percentage change per year in the diatom. So globally, minus 1.22%. Between this, so the rate of change. Notice that the other paper in 2010 showed it says it's about 1% decline, but it's 0.9914%. So in summary, we have a real problem in the oceans, where the base of the food chain in the oceans is severely threatened, and